Okay, so this particular one, it's creating and using arrays is the section, and it's which of the following options correctly declare a variable that can directly reference an array of 10 ints. So we're talking about primitives here. So we have to select two options, int array IA, yeah, that's absolutely fine. The size is never on the left-hand side, so that's wrong there, that second one. The third one, int IA array, so the array symbol, if you like, is never, doesn't matter which side it's on the variable, on the left-hand side there or on the right-hand side there. That's okay, both of those are fine. So there are two options, but let's look at the other ones. Here we're talking about an array of objects. An array of ints is an object, but it's not an object array. So that's what's wrong with that one. And again, it's not an object array, and then you've got 10 there as well. So evaluate that. Note that an array of integers is an object. So you can, there's an object. New int array 1, 2, 3, that is valid. But it is not an array of objects. So you can't go and say new int 10 and put that into an object array. What about the difference between the placements of the square brackets? Well, there's an int array I and j, so both of them are arrays of integers. But here, this is an array of integers called I, and that's just an integer j. Okay? The next one, what will happen when the following code is compiled and run? Okay, so you're declaring an array here, new int, and there's 0. No space been allocated to it. And then in a static initialization, you're saying x with an index of 0, which would be assuming that this would be a 1. So that's a problem. That's an array index out of bounds exception. However, because it happened in a static initialization block, so that's a curly brackets with the keyword static in front of it, that gets wrapped in an exception initializer error. Okay, so it's not array index out of bounds, it's that one there. That's what happens in that instance if you get an error in a static initialization block. Remember that a static or an instance initializer can only throw a runtime exception. If you try to throw a checked exception from a static or instance initializer, okay, to the outside, the code will not compile. So that's what I'm reading down here. So if you're inside a static initialization block or an instance initialization block, in other words, just the double quotes or the curly brackets, excuse me, without the keyword static, and this will be outside a method now, but within the class, if you try to throw a checked exception from there, you get a compiler error. Okay, it's only supposed to be runtime exceptions from there. Okay, the following class will print index is equal to 2 or assigned to when compiled and run. So here we are in main. Okay, int index is assigned 1. We try the following. Call the function or the method getArray, and then index is assigned 2 is the subscript, and then we're doing a plus plus. So what this question is about is this getArray is the method here. It's going to return null for the int array. Okay, that's a valid return for any array because an array is an object. Okay, and null is a valid reference, except you can't dereference it. So the question is, will that get done first and throw the exception immediately, or will index be set to 2 first and then this null exception gets thrown? And the answer is that the subscript bit there has to get evaluated first before whatever is over here on the left gets evaluated. So in other words, index is going to be set to 2. Then we're going to call getArray. That's going to come back with null. Then we go and try and dereference null, which gives you a null pointer exception. We catch it in here. We don't do anything with it, but the exception is now handled, so we can proceed as normal. And we can output index is assigned 2, because it did get set there from 1 to 2. So the answer to that is true. And there it goes into detail about that. Okay, the next one. What will the following code print when compiled and run? So we're inside a main. We create a new order test, which is this class here. Then we go along and we create a new string array, ARR, is assigned new string array 2. So what does that put into ARR? 2 null references. So ARR is a reference to an array object. There's 2 elements in this array, and both of them are set to null by default. So we come along then and we pass this array reference up to init data. We call it ARR up here. And then for each string in ARR, we do the following. Now, that's going to be null for the first one and the second one. And now we're going to have a problem. The fact that it's null is not a problem, but if you try to dereference the null, if you try to call a method on it like there, stir.concat, when stir is null, well, that's null.concat. That's a null pointer exception. And a null pointer exception is a runtime exception. See, there's no try catch blocks here. So it's a runtime exception. Okay, you create a string array of 2 elements. ARR is therefore not null, but each element of the array is not given any value, and therefore they're null inside the array. When you call a method using that there, and when that's null, it will generate a null pointer exception because it's null. Okay, number 5 is, I have a YouTube video for that. 7, which relates to multi-dimensional arrays. In this question, we are given a string array which has 3 dimensions, and there is the array outlined. And then we're asked to output ARR with index 0, 1, 2. So I'll go through this from this perspective, but then I want to draw it out in memory to help, and then I want to look at it in a code editor as well and go through some of the outputs of other indices. So here we've got a 3-dimensional array, 3 sets of square brackets, which results in 3 curly brackets there leading you off at the start. So that's the very first dimension. Then you've got the second dimension, and if you like, the last one. And that's the last one is an array itself. This curly bracket here will be an array of arrays. And the first one will be an array of arrays. So we're going to have a look here at how they're grouped. That is the first array, and it's matched off left curly bracket with the right one. And there is another one. And then we have a right curly bracket matching here. And given that the next set of curly brackets essentially is your outer one, that's where we're matching. That's what we're looking at now, an array of arrays. That's our first entry in our 3D array. That one there. Starting out with 2 curly brackets, going down to 1 by taking off the right curly bracket, then we go back up to 2, then we come back down to 1 needed, and then we match it off. So that's the first one, and we have a comma after it. So we need 2 left curly brackets to start us off, and then we need to match them. So here we go again. This is our second entry, 2. That brings us down to 1, and that brings us down to 0, and then there's a comma. So that's the second entry. So it's be index 1 of that there in that particular one there at that first subscript. Here's another one. and a comma following it. And then there's left, left, right, a left, and a right, and a right. So that's another one. It's the last one. And there is the overall outer one matching with the very first one. So we were asked to output 0, 1, 2. Well, as we saw, we follow that one. That's index 0. Within that, we have to get index 1, which brings us to that array. And then finally, we have to get index 2 of that array, which is null. So the answer is it will print null. So evaluate that, and there it explains what the index 0 is. Index 1 within that is the DE null, and then index 2 within that is null. So now what I'd like to do is I'd like to draw that up and talk about how it looks in memory. Hopefully that'll make it easier to understand. So here is the code as it's loaded in, and then here I have what it looks like in memory. So we have 4 elements in the outer array, the first level, if you like. That one there. That is an array of arrays of arrays. That's what the outer one represents. And then we get the next level down, which is there, starting there and ending there. So that's an array with 2 entries in it. There's the comma separating them. So there it is. It has 2 entries in it. And each one of these refers to an array. An array is an object. That's why I represent them with circles. And inside the first array, you've got A, B, C, and the second one, it's D, E, null. So there you go. A, B, C, and D, E, null. And the question was, go to index 0, that gets it down to this level, then use index 1 to get down to the last level, and then index 2. And that's how we ended up with null. Okay, but let's talk about the other ones. This was a 2-dimensional array here, starting at that curly bracket and ending at that curly bracket. The second array is just null. There's an array, curly brackets around it with X. So that's how you represent that. This is the reference to it. The first one is referring to another array with X in it, and then the second one is just null. The third one is a 2D array, 2 dimensions, 2 sets of curly brackets, and just Y inside it. And there's the closing off of the 2 curly brackets. So that's an array of arrays, and that's all that's in it is the Y up here. And then the last one, there's your outer curly bracket, there's the matching one, and we've got an array with ZP, and then we've got an empty array. So there's your 2D array referring to another array, ZP, and then I've represented that using just a dash there for an empty array. It wouldn't have valid indices as such, but it's still an object. So now what I want to do is I want to have a look at that in NetBeans and see what it will look like in code, and we start looking at other indices. So here is the actual 3D array that you're given. Okay, that's your ARR0 up there at the top. Then there's ARR1, ARR2, and ARR3. So this is the overall outer array, and I'm just using the yellow to show you. Okay. Then within that, and I've tabbed it in, that's ARR0. So that's the first 2D array. That's your 3-dimensional array. Now you're down to the second dimension here, which has another dimension inside it, which is those 2 guys there. So they represent ARR00 with indices 0, 1, 2 respectively. So ARR000 is A, ARR001 is B, and ARR002 is C. The next one over here is ARR1. Okay, ARR 10 with an index of 0 gives you that X. That's an array, remember? That represents an array. And if you have ARR 11, well, if you try to dereference that, you get a null pointer exception. Okay, if you systemed it out.println, ARR 1, you'll get null. But if you try to go and dereference it, you'll get a null pointer exception. Then we've got ARR 2. This is the overall first index now. So that represents a 2-dimensional array. And there's the third dimension. So it's referring to an array with just Y inside it. So that would be ARR 200. ARR 3 is the last one. So that's ARR 30, and that'll be 0, and that'll be 1. 3 indices been used. Subscripts. 3, 0 will get you to this array, and 300 will give you Z, 301 will give you P. 31 is an empty array, and if you try to index it, you get an array index out of bounds because there is nothing inside there. So let's look at some outputs that when I ran it with certain values. So when you output the ARR, you'll get this type of output there. 3 left square brackets means we have 3 dimensions in the array. There's 3 of them there, 1, 2, and 3. And that's why you get 3 left square brackets here. That's the default output from toString if you're passing in an array. The L means it's a class. What class? What's the type? Java.lang.string. It's a string array. And then that's just an @ sign. There's a semicolon, then there's the @ and the hash code, which you're probably familiar with normal objects. If I go and I say ARR 0, like I do here, then it's the 2-dimensional array with the output following similar style and pattern after that. L representing the class, then the name of the class, semicolon, and @ and the hash code. And then ARR 00 is a 1-dimensional array, 1 left square bracket. So we output 000 and we get A, 001 we get B, 002 we get C, which should be right. 010 is D, 011 is E, and 012 is null. These guys up here. Okay. 100 is X, 11 is null, and if you try to dereference it, you get a null pointer exception. 200 is Y, 300 is Z, 301 is P, and 31 is an array. So 31 is an array. If you try to index it, you'll get an array index out of bounds exception. Another one here now I'd like to play for you as well. Question 2.1398 from Enthuware, which deals with a 2D array. So in this program here, we are asked to run the JVM with that particular class, which is this, the fun with args, passing in A, B, and C as our runtime arguments. Now the main method is actually overloaded. There's no problem with that. The one where the program will start is the one with the string array as opposed to the one with the 2D string array. So it's going to start here. We create an instance of fun with arguments. Then we create a 2-dimensional array based on the arguments that comes in. So the curly brackets denotes an array, and inside that we have an array. So essentially, you're going to have an array with one entry in it referring to the args array, which has A, B, C inside it. So we call the main method passing in our 2-dimensional array up here. It's called args in here. And then we output args 01. Now there is only one entry in the args, so 0 is the only index that will be valid here. And then we want the second one, which is B. So I'm going to draw that out now, and we'll discuss it then. And hopefully that will validate this answer, which is B. So there's the code loaded up, and we'll go through it. So we're passing in A, B, C into our program, and it's called args. And this is inside the main. I'll just put in that to say that this is where main, the string array, starts. So args here is a reference to an array. An array is an object, and we've got A, B, and C inside there. And they're strings, A, B, and C. So that's the args array, referring to our string array. Now, this line here is where it all gets interesting. We're going to create a 2D array reference, new args, which is essentially an array with a reference to args encapsulated inside it. So what that does is the following. And that has an index 0 referring up to the args array. So it's an array of arrays where you have an array referring to another array. We then go and we pass new args, a copy, because it's called by value in Java, and then this is the 2D array args, different args inside the main. So inside this overloaded main method, we have an args reference, and it's referring to whatever new args was referring to. So this args, this local args here is referring to whatever new args in the other method was referring to. So then we go and we output args 0, 1. So that is go and dereference args, go to 0, and then go to 1, which is B here. And there you see the answer. We're on to number 7. Okay, so given the following code, so A00 is 1, A01 is 2, and A10 is 3, and so on. What can be inserted independently in the above code so that it will compile and run without any error or exception? So we want to look at these declarations. So I'd like to draw that up to discuss what the array looks like. So we're going to have two-dimensional array in each of them. And remember, the first dimension, as we can see it here, has an index of 0 and it's an index of 1. So it needs to be 2. The second one was 0, 1 there, but it was up to 4 here. So we will need 4 anyway for the second one and 2 for the first one. So you could say 2 by 4 would certainly work, but we want to go and double check that here now. So I just want to go and load that up here. So there is the code. Okay. So the first one, option A, is a 2D array, int A, new int 2, and then the second subscript there is not filled in. So what does that do? Well, that gives you an array. So this is A. A is a reference to an array, and because of the 2 here, we have 2 entries, but because this is left blank, if you like, or nothing in it, they are both null. Okay, so that's not going to work because we're dereferencing index 0. We're going to get a null pointer exception there, and the same for the 1, because if we try to dereference these guys, we're in trouble. Let's look at B. What will B give us? Well, B is saying the first dimension I want 2 and the second dimension I want 4. So what that is you've got A referring to the first dimension, and you've got 2 entries in the first dimension, and then each of these is referring to an array with 4 entries. And they'll all be given 0, 0, because it's an int array. So B is correct. That's one of them. B is fine. There's no problem there. I'm not going to have any problems dereferencing A0. So that'll be A0 there. And then you go down to any A0. 1, it's here. That's okay. There's extra ones, but that's fine. A1 is this guy, obviously. And then up to 3. That's fine. So it's not going to give me any problems. Let's look at C. C is new int array 4, 2. So we're going to have 4 in the first dimension, and each one of those is referring to a 2-element array on the second dimension. So it's easy enough to figure it out. Now that isn't going to work for us because we are looking for A12 and A13. Sorry, that's this guy here. So the C guy that you see here, 2D array 4, 2. There's the 4, that's dimension 1. And then this is the second dimension at the second level down. So if I say here, this is your dim 1, and then this is your dim 2, your second dimension, which is 2. Each of them has a 2-element array because of the 2. That's the second one. Now, that's going to cause us a problem because we're saying we want A12 and A13. So if I go A12, I'm out of bounds here, and A13 is out of bounds. So the code specifies that in the second element, on the first dimension, we should be able to go to the third and the fourth element in the second dimension, and we can't with that declaration. So C is incorrect. Okay, D. So D says, okay, I want a 2D array, and it fills out the second one. However, unlike A, it goes and it assigns arrays into A0 and A1. So what that looks like is you've got your A referring to 2 up here. Okay, now they'd be initially null, null, like they were up here. However, the next 2 lines, A0 is assigned new int 2. There we go. And A1 is giving new int 4. Okay, now that's okay. D is okay as well, because it covers all of the options that are up here, A00 and A01. So that's A00 and A01, that's fine. And then A1 has to be able to go up to, so A1 has to be up to 0, 1, 2, 3, and it does. So the last one that leaves us with is E. And E says 2D array, new int 4, doesn't fill in the second subscript. A0 is new int 2, and then the next one is A0, A1 is new int 2. So that gives you, so this is E, and you've got A is referring to an array where it's going to be 4 entries, okay, in the first dimension. Now, what I will say here is that the A0 is new int 2. This is the second dimension. 2 of them for that guy. And same for the next one. And those 2 are left at null. They're both null. Now, that's going to be a problem with the code A12, A13, the last 2 lines there. A12, A13, A10, A11, but they can't give you A12 and A13. So E is incorrect as well. So the answers there are B and D. Let's just go back here. And we want B and we want D. And there they are. So the next one here, we have a data array is assigned new string 4. Okay, now that gives you a data array with strings in it. Now, it hasn't been initialized, so therefore they get null values, 4 nulls. Okay, and that's because string is a capital letter, so it's a class. It has methods and all that. If it was an array of persons, they'd be nulls as well. If it was an array of int small I, they'd be zeros. Okay, so it's important to remember that your arrays get default values, even if they're local. Now, what happens here is that the 0 subscript is missed out. So the array in memory, you've got Bill, Steve, and Larry. Data ARR 0 is still null. Index 1 is pointing to Bill, index 2 is referring to the string Steve, and index 3 is referring to Larry. And what we're doing is we're going through each one of those strings in the array, and we're outputting what we find there. And it's not dereferencing it. We're not trying to call a method on data. If we were, if I was saying 2 lowercase, for example, data.2 lowercase, you'd get a null pointer exception for the one that's at index 0. But we're not doing that. And if you put in null into a system.out.print or print line, it'll print out null. So what you're going to get on this one is the bottom one. Null, Bill, Steve, and Larry for that reason. No exception generated. Number 9. Which of the following code fragments will successfully initialize a 2-dimensional array of car named CA with a size such that CA with an index of 2 in the first dimension and an index of 3 in the second one refers to a valid element. In order to have a CA2, we need, well, 0, 1, 2, we need a 3-dimensional array in the first dimension, and then we need a 4, 0, 1, 2, 3. So we need a 3 by 4 array. Okay? So if we looked at the first one, what you'll get for the first one is a 2-dimensional array. That's the first dimension. And so it's a 2 by 3. So in other words, there's 2 elements in the first level, and each one of those refers to a 3-dimensional array with A, B, C in it. So I want to just draw that out because it's easier to see it. So that first one, you're going to create CA, which is a reference to, there's 2 dimensions in the first. That's because of, there's curly brackets around something like that means that's an array. And there's the second array. Comma separated, first entry, second entry. This is going to be the first entry coming out to an array, and then we're going to have the second one coming out. So that's referring to the array with A, B, C in it. And this guy is the same thing. A, B, C. Okay? So that's what 1 did. Does that give us a 3 by 4 array? No, we haven't got 3 here. Not to mind getting 4 here. So 1 is not good enough. 2. So let's look. 2D array, 3 in the first dimension. Okay, so that will give us something along the lines here of, and we want 3 in the first one. Okay, and then we have a for loop going to the length of the CA array, which is 3. Okay, I less than 3. CAI is a new car 4. So what that does is it goes to this guy. We've got a new car 4. 1, 2, 3, 4. This guy gets 1, 2, 3, 4. And the same with this guy. 1, 2, 3, 4. So 2 is right. We get a 3 by 4 array there. So there's the first dimension, which has got 3 entries in it, and each one of these guys down here has 4. So if we look at what we were trying to get is 2, 3. Well, there's index 2, and then there's index 3 down here, over here on the right-hand side. So that's what we were actually trying to access from the code. Let's look at the remaining options all the same. Make sure we're right. This third one does the same thing as the first one. This is just syntactic sugar. Less typing, if you like. Java creates a character array from that, and that puts in this stuff in the background. So here's a new character array, and these are the values. Here's a new character array, and these are the values. Again, there's only 2 of them, like there's only 2 of them up here, and each one of them has an A, B, C. So you're going to end up with a structure like this, like we did in A, or number 1. Same problem. What about this number 4? Problem straight away. You don't ever put the sizes on the left-hand side of an array declaration. Ever. Doesn't compile. Okay? This next one isn't even a 2-dimensional array. You've only got one set of curly brackets. Okay? There's the outer dimension, the first dimension up here. And then there is the inner dimension, the second one. So the first dimension is represented by the outer curly brackets, and the second one by the inner. That's why in the previous question, I was saying 2 sets of curly brackets, because we did 3 dimensions in that case. Once you took out the outer set of curly brackets, we had 2 sets of curly brackets to worry about. Here, once you take out the outer set, then you've only worried about 1 set of curly brackets inside that. If you take away the outer set here, you've got nothing on the inside. Plus, they're strings, they're not characters. Characters are always in single quotes. And a string is not equivalent to a 1-dimensional array of characters, by the way. Okay, the next one here. What will the following program print? Well, you've got I is set to 4, and you've got a 3-dimensional array, and it's a new int, and basically you go left to right. No surprise there, really. I is set to 4, so the first dimension is 4. Then you change I to 3, so the second dimension is 3, and now the last one is 3. So when you output IA length, okay, that's going to be 4. That's the top dimension there, which we've set at 4. You go to dereference that to go down to the next level, well, you're after changing it to 3 there. And then you go down 2 more levels and get the length of that array. All right, then that's going to be 3 because it was changed. So just quickly draw that up and show you that's the answer. Okay, so it's easy enough to see it when we look at it in the drawing on the board. So if you're saying that the first dimension is 4, then you've got IA is referring, and there's 4 entries up here. So that's the first dimension, dimension 1, and that's set to 4. Now we're saying the next level of your 3-dimensional array has 3 in it. So each one of these at this level has 3 entries in it. So that's D3. It's the second dimension. Second dimension has 3 entries in it, each of them. And then you go down to the third dimension, and it's 3 again. So we go down to the dimension 3, and it's 3. So we're talking about 3. I take this guy, 3. Take that guy, 3. They don't have to be consistent like we saw in one of the previous questions. If they're not consistent, then they're jagged arrays. That's what they're known as. So you could have maybe 3 here and 2 there and 5 there, but not the way this is declared, okay? The way this is declared, they are going to be consistent. And let me go back there because I don't want to be confusing anyone by saying just popping jagged arrays in here. What I mean by jagged arrays is this type of idea here. So we've declared 2 entries at the top level, but then at the next level down, the first one has 2 entries, so we're referring to an array with 2 entries, and the next one is referring to an array with 4 entries. But the way this particular question is declared, 433, they all have the same idea, or they all look the same in memory like that.